So far, we've dealt with simple chains and rings of carbons. But let's think about what happens when things get a little bit more complex. Let me just draw a molecule here, and we can think about how we'll name it. So let me draw. So let me draw it like. Let me draw it like that. So here we don't have a simple chain. It branches off at some point. So what we do in this situation is we find the longest chain in this molecule. And let's think about what the longest chain is. If we start here, we get 1, 2, 3, 4, 5, 6, 7, 8 carbons. If we start here, we get 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So what we do is we look at the longest chain. The longest chain is this one right here. Let me do this in a different color. So this is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. And so that will be kind of the core of our naming. So it's 9 carbons. So that right here, longest chain has 9 carbons. You can kind of view this as the backbone of our molecule and also the backbone of our naming. 9 carbons. So we're dealing with a nonane. Nonane. Remember, 9, non for 9. And then ane because we're dealing with an alkane. We have all single bonds over here. Now, what do we do with this thing over here? Well, what's kind of sticking off of this chain? Well, we have one carbon here that's attached to the chain, right? This carbon is bonded to a carbon on the chain. If we wanted to draw the entire molecule, we could draw a carbon here, and it would be bonded to 3 hydrogens. But that is all implicit. But what is this thing right here? Well, it's one carbon. So you might be tempted to say it's methane, but it's not methane because it's attached to other things. But it would be right to use the prefix meth. So this right here, you would use the prefix meth. So this is one carbon. So you would want to use the prefix meth. But because it isn't the main chain, it is added to something else, we don't write methane, we write methyl. So let me write this right here, methyl. Methyl. So this means that it branches off longer chain. Longer chain. So this molecule right here would be called, and actually there's one more thing that we have to think about. This thing could have been, we could just call it methylnonane. Let me just write that down right now. So we could just call this right from the get-go. We could call it methylnonane. Methylnonane. But there's one problem with just calling it methylnonane. This is methylnonane, but let me draw it. So this thing I just drew here, this is 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the nonane. And the one I drew here is 1, 2, 3. The methyl is right over here. That's what I just drew. That is, let me draw it the same color. So this is what I just drew. But maybe, what if it was something like this? What if it was 1, 2, 3, 4, 5, 6, 7, 8, 9? And let's say that the methyl group was, instead of being right here, let's say the methyl group was right here. So how would you name these two things differently? This name right now does not differentiate between the methyl group being on this carbon versus the methyl group being on this carbon over here, or this carbon over there. And what you do in this case is you number the carbons on the longest chain, on the main backbone, and you number them so that the methyl group is attached to the lowest possible number. So there's two possible ways to number this chain. You could start here as 1, 2, 3, 4, 5, 6, 7. Then you would say that this would be the methyl group is attached to the 7 carbon. Or you could start numbering from this end of the chain. It would be 1, 2, 3. So it could also be attached to the third. 3, 4, 5, 6, 7, 8, 9. So you want to number it so you're closest to the methyl group. So you want to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, this would not just be methylnonane. This thing right here would be 3. Let me make this very clear. It would be 3-methylnonane. Because the methyl group, that one carbon, that one CH3, is attached to the third carbon on our nonane backbone. So that right there is 3 methylnonane. Since I drew this out, what is this right here? Well, once again, we have this nonane backbone. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you want to number it so that this methyl group is at the lowest number carbon as possible. So it's closer to this end than that end. So it's 1, 2, 3, 4. I'll do that in magenta. And then you could keep numbering. 5, 6, 7, 8, 9. So this one is going to be 4. And then you have your methyl group. It's just one carbon sitting right there. So 4 methyl 4-methyl nonane. 4-methyl nonane. Now let's go the other way around. Let's say we start with the name and we want to figure out its formula. And hopefully this gives you a good understanding how things will get more complex. And over the next few videos they'll get more and more complex. But you'll see it's all at least reasonably logical. So let's say I were to give you let's say I were to give you let's say I were to give you let me think of one. Let's say 2 propylheptane. 2 propylheptane. So how do we take this apart? So the first thing you see, it is an alkane. It's all going to be single bonds. Heptane, this is kind of the core. So the longest chain here, hept is the prefix for 7. So this tells us, let me make this clear. This tells us that we're dealing with all single bonds single bonds, single bonds. That's what the ane tells us. If we had double bonds, it would be ene. Triple bonds, eine. We're going to see that in the future, but let's stay simple right now. The hept tells us that we're dealing with seven carbons. 7 carbons. And then what does this 2-propyl means? Well, propyl tells us what was the prop prefix? If methyl is 1, ethyl is 2, propyl is 3, butyl is 4. So this is a 3-carbon group. 3-carbon group. And it's going to be attached to the second carbon on the heptane. So let me draw the heptane chain. So we have 7 carbons. So 1, 2, 3, 4, 5, 6, 7. And then so let me pick a good color here. On the second carbon, so if we just number it 1, 2, 3, 4, 5, 6, 7. On the second carbon right there, we have a propyl group. We have a propyl group, but there's a 3-carbon group. So let me draw the propyl group. So we have a 1, 2, 3. 3-carbon group, and it's attached at the second carbon right there. So this molecule, 2-propylheptane, looks just like this. Let's do another one, maybe one that seems a little bit more difficult. Let's say that we have 6 let's say we have 6-butyl tetradecane. Tetradecane. And all of these might seem a little daunting when you see it at first, but if you really just break it up, it actually is pretty logical. So once again, we have the ane there, so it's all going to be single bonds. What is tetradec? What is that prefix? Well, dec is 10, and then we have tetra, that's 4 plus 10, that's 14. Tetradec is 14. So this is telling us that we're dealing with a 14-carbon chain. 14-carbon chain. So let's draw that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14-carbon chain. And if we number them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, this tells us that the sixth carbon will be butyl, will be a butyl group. So let's see, the sixth carbon is right here. And butyl, and you should memorize this, methyl is 1, ethyl is 2, propyl is 3, butyl is 4. So we have a 4-carbon group. So let me write this in pink maybe. So this is a 4-carbon group. 4-carbon, it's actually, you call it an alkyl group. It's attached to something else. So on the 6th carbon, we have a 4-carbon group. So let me draw it this way. Oh, this is fine. Let's say it's we have 1, 2, 3, 4. So that is our butyl right there. And it's attached to the 6th carbon. It's attached to the 6th carbon right there. So this is what our molecule would look like. Now, let me ask you a question. Would you ever see a 9-butyl tetradecane? Would you ever see a 9-butyl tetradecane? So something where, so let me redraw it like this. So a 9-butyl tetradecane. So it would have a butyl over here. 1, 2, 3, 4. 1, 2, 3, 4. Would you ever see a 9-butyl tetradecane? Will you ever see that written? You might say, oh, yeah, Sal, you just drew it. And the reason why you won't ever see that written is because there's a better way to number it if it's like this. Instead of starting over here at 1 at this end, you'd want to start 1 at that end. So instead of saying 9-butyl tetradecane, you should number it the other way. You should say this is 1, 2, 3, 4, 5, 6. So this is actually also 6-butyl tetradecane. Make sure I got that there. 1, 2, 3, 4, 5, 6. So instead of starting from the left and making this the 9th carbon, you always want to start numbering from the direction that has the lowest number for the first group.